Okay, Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. My name is Muhammad Sharif from Group 2 under the course SKEE2073 Signals and Systems, UTM Space Campus Kota Kinabalu. Today, we will walk you through our project involving signal analysis, addition, and convolution using both mathematical methods and MATLAB simulations. Our task focus on understanding the behavior of triangle and rectangular signals and how they interact mathematically and programmatically. So this is our team member. First of all, we have Muhammad Zulfadli bin Ruslin, number matrix SX231666 EEEHF11. Secondly, we have myself, Muhammad Syari bin Madbi, number matrix SX23166 at EEEHF11. And lastly, we have Zulkifli bin Ramli, SX23167 EEEHAF11. Each member contribute to coding, solving mathematical calculation, and preparing this presentation. Introduction. In signal processing, linear time invariant LTI systems are widely used due to their predictable behavior. The convolution operation is a key tool for analyzing these systems, as it determines how an input signal interacts with the system impulse response to produce an output. This assignment focuses on understanding convolution mathematically and implementing it in MATLAB to analyze the response of LTI systems. By the end, students will be able to compute and visualize convolution result, gaining insight into its significance in signal processing. This is task 1. Given x1t is a triangle and x2t is a rectangular signals. Number 1. Develop the MATLAB program of the signals as shown in Figure 1a and Figure 1b and regenerate the signals. Secondly, by calculation, determine the additional of both signals zt equals x1t plus x2t and verify by MATLAB. Number 3. By calculation, evaluate the convolution result yt equals to x1t multiply x2t or yt equals to x2t multiply by x1t and verify by MATLAB. And so this is mathematical solution for task 1. So for task 1, given two domain signal, first x1t in triangular signal, and this is the step function for x1, and x2, this is for step function for rectangular signal. So given that the additional of both signal x1t plus x2t, so for we evaluate the sum zt over different range of t. First we have x1t equals to 0. Next 2t is equals to 1. Zt is equals 2t plus 1, and zt minus 2t plus 4 plus 0, zt is equal to e minus 2t plus 4. So combine the result of zt at the different range of t. So this is the expression for zt, and this is the graph, final graph from t minus 1 to t is 0, constant value at 1. From t0 to t is equal to 1, increase from 1 to 3, and from t1 to t decrease from 2 to 0. This shape combines a step, a rising slope, and a falling slope, visualizing the additional of both input signal. So this is the convolution of x1t and x2t. Yt equal to x1t multiplied by x2t. So this is the formula for when t and then when 0. So this is the formula for the convolution. So we combine the result of yt at the different range of t. So we get this as the graph. So this is the MATLAB signal operation for task 1. So step 1 is define time vector. So they give the MATLAB code. This creates a time vector t ranging from -2 to 3 with increment of 0.01. This vector will be used as the time base for signal generation. Step 2, define triangle signal times 1 t. They give the MATLAB copy the code and initialize times 1 as a triangle waveform, linearly increase from 0 to 1 between t equals to 0 to t equals to 1. Linearly decrease from 1 to 0 between t equals to 1 to t equals to 2. And step 3, define rectangular signal times 2. So they give the MATLAB code times 2 equals to 0, size t, and define a rectangular pulse times 2, t with amplitude 1. The pulse is active between t equals to -1 and t equals to 1. So next, calculate the sum of signals. Z equals to x1 plus x2. And then calculate the convolution. Y equal to convolution function x1, x2, same 0.01. Then next, plot the signals. And first, subplot. And this is the second, third, and fourth subplot. And then this is 5 and 6 subplot. So we combine this subplot and the code, and lastly, and this is the result for triangle signals and rectangular signals for figure 1 and figure 1a and figure 1b. So this is the result. So this is how the coding combined. We use the MATLAB application. Then this is the result that we got. That's all for task 1. Thank you. So next, this is for task 2, figure 2a and figure 2b. As we can see, given GT is a triangular and HT is a rectangular wave signal. First, develop the MATLAB program of the signal as shown in figure 2a and figure 2b and regenerate the signals. 2. By calculation, determine the additional of both signals zt equal to gt plus ht and verify by MATLAB. And thirdly, by calculation, evaluate the convolution result yt equal to gt times ht or yt equal to ht times gt and verify by MATLAB. So this is the mathematical solution. So this is mathematical solution for task 2. As you can see here, we got the question number 2 for mathematical equation for signal gt and ht in form unit step function. And then question number 3 is convolution solution. Next, we have MATLAB solution. So this is the command for task 2. First, define time vector and initialize the triangular signal for ht. Define the start and end of the ramp. Find the index for the ramp. Create the ramp. And set the values to 0 outside the ramp. Define ht rectangular wave signal. Calculate the sum of signal. Calculate the convolution. And plot the signals. And next, plot the signals and subplot. And we have subplot first, second, and this is third, fourth subplot. And lastly, we got the result here for figure 2a and figure 2b. So this is the result. So we generate the result using the MATLAB application, and we put the code like this. So we put the command, and then we combine the command, and then we got the result for figure 2a, for figure 2a and figure 2b. And we got the sum of signal here and convolution result here. And that's all for the task 2 in MATLAB solution. And thank you.